Okay, so as our warm up, we listed off some strategies for solving these. Okay. So if we're talking about exponential and logarithmic functions, in both situations, changing forms is a good strategy. Okay. If our exponent is in the, or if our variable is in the exponent, rewriting it to logarithmic form would take that exponent out, or the variable out. If a variable is inside of the logarithm, rewriting to exponential form would take that variable out. Okay. The one-to-one property, there is a one-to-one property for both logarithmic and exponential functions. Whether we rewrite these to be the same base and we compare exponents, or if we have logarithms that are equal, we know what's inside is equal. All right. And then logarithmic properties. I'm really glad. I think it was Pod 5 mentioned that. If we have multiple logarithms with the same base in our equation, condensing is going to be very helpful for us. Okay. So these are all things that we practiced last week. Okay. So now we're going to use them in various ways to help us solve some equations here. Okay. So first we're going to look at some exponential examples. This first example is one that should look familiar to last year. Okay. If we have an exponential equation where our variable is in the exponent, before you can rewrite this equation into logarithmic form, you must do what? We cannot distribute that power through, all right, because exponent comes before multiplication in the order of operations. We would want to divide that 2 over. You need to isolate your base to the power, okay? Since 5 to the 2x plus 3 is not by itself, we need to get it that way. So if we divide by 2, we have 5 to the 2x plus 3 equals 16. Okay, now base to the exponent is all by itself, and we can do what? Rewrite it. And how can we rewrite this? Log, base. What's the base? 5 of 16 equals 2x plus 3. Now you can see that this is a simple linear problem. Okay? Can you evaluate log base 5 of 16 in your calculator?
Yes.
Yes. Okay? So evaluate log base 5 of 16 in your calculator. Okay? Do not round this number at all. Don't write it down. I would not write it down. If you do write it down, you're going to have to write down a lot of decimal places. I think this is something we can think through in our head. With that number, what are we going to do with it to get x by itself? What? You said it, Cassie, what you saying?
Subtract 3.
Subtract 3. And then with that number, divide by 2. So you're taking Log base 5 of 16, you're subtracting 3 and dividing everything by 2. What do we get? Excellent. Biggest thing here, make sure you isolate your base to the power with the exponent before you rewrite it into logarithmic form. Okay. All right, here's a fun example. E to the 2x minus 4 e to the x minus 5 equals 0. It looks very different from what we're used to seeing. We have a couple different e to a power. Okay? Does anybody have any ideas? Yes. Factoring, that's very interesting. And how might you suggest that?
Instead of like x is
Okay. So e to the x and e to the x instead of x and x?
Yeah.
Okay. How do you guys feel about that? You seen it? Okay. We'll come back to this, Sean. I like what you're thinking. How about this? If I asked you for x squared minus 4x minus 5 equals 0, what would you do? You would factor to x minus 5 and x plus 1, right? Okay. Look at this pattern. E to the 2x minus 4 e to the x minus 5. We can actually factor this to e to the x minus 5 e to the x plus 1. Because if we think about foiling this, e to the x times e to the x is e to the 2x, because we would add our exponents. E to the x times 1 plus negative 5 times e to the x, when added to be our negative 4 e to the x. And of course, negative 5 times 1 is 5. Can you see the similarities? Does that make sense? Okay. So now that we have it factored, what do we do with each of the factors? Okay, so we have e to the x minus 5 equals 0, and e to the x plus 1 equals 0. So let's talk about this factor first. If e to the x minus 5 equals 0, how do we get x? Okay, so add 5, e to the x equals 5. And then what would we need to do? Okay, logarithmic form. So log base of equals x. Which is what, Joe?
1.6.
Okay. Over here, we have e to the x plus 1 equals 0, which means e to the x equals negative 1. Which means what?
Well, the first one from 1.6.
Oh, I'm sorry. I misheard. How do we rewrite this? To solve for x? Natural log of negative 1. Can we take e to a power and get negative 1? Okay. When you are solving these equations, it is possible for something to work algebraically, but not back in your original equation, okay? Since we're working with logarithmic functions and exponential functions, we have some restrictions, right? Our domain for logarithmic function is restricted. Our range for an exponential function is restricted. So sometimes we're going to get things to work out in our algebra that don't actually work back into our original function. Okay, so e to the x plus 1 equals 0. Okay, that works algebraically, but we can't get an answer out of that. So we only have the natural log of 5 as our answer. Okay, luckily you have your calculator, so if you have a brain fart and you put this into your calculator, what is it going to say? It's going to say an error. Okay. All right. One more type of exponential example, and then we'll do a couple of logarithmic problems. Okay. What is the issue here? The bases are different. Is there any way for us to write those bases the same? If it was 2 and 4, that'd be cool, right? But 3 and 4, they don't have anything in common, do they?
Well, we make it.
Okay. So if the 1-to-1 property is not going to work for us, we can think about the logarithmic 1-to-1 property. Okay. What's true about two logarithms that are equal? Well, inside is equal, right? Okay. So what we can do is we can go backwards. If these two are equal, then the natural log of 3 to the x must equal the natural log of 4 to the x minus 1. Why would that be helpful? It really doesn't matter what logarithm we choose. Okay? As long as the logarithm has the same base, we can use this property. Okay? Natural log may be just the easiest one to use. It's less to write. The button's easier to press in our calculator. Okay? Now, why did we do this? What can we do with these? Well, we can't set those equal, but we have a logarithm where inside it's raised to a power. So what can we do with that x? Like you just forgot everything. What can we do with this x? I have a logarithm where inside I have 3 to a power. Well, we're going to write this a little bit differently. What could we do with that power?
Put it on the outside.
We multiply it out in front, right? X, natural log of 3, right? Which means how can we rewrite the right side? X minus 1, natural log of 4. Okay. So now, eventually, I'm going to need to solve for x. Right? Okay. So what we can do is we can say x natural log of 3 equals x natural log of 4 minus natural log of 4. Can I break it apart like that? If x minus 1 is being multiplied to the natural log of 4, can I write x natural log of 4 minus 1 natural log of 4? Why not? Isn't this being multiplied to the natural log of 4? So we can distribute, right? Okay. So now, we have two different things with an x in it, correct? what would be a good idea? If I have two different things with an x, should we put them together? So I'm going to subtract this over. So what can we do with that left side? What do both of those have in common? An x. We're trying to solve for x, correct? Can we get x by itself? Divided over. So x is negative natural log of 4 divided by the natural log of 3 minus the natural log of 4. And we can type that into our calculator now. Okay? I know this is an intense example. Okay? This is probably going to be the hardest problem on your assignment. Okay? Yeah.
So, since the numbers look the same as our bottom, can you cancel it out?
You mean here?
Yeah.
We cannot do that. Since there's subtraction here, we can only cancel if there's common factors. So if we have, if we are separated by multiplication, we can cancel. Okay. All right. So what does this approximate to? $4.819. Like I said, this is the hardest problem we're going to do. But I like it because it forces you to use a lot of different strategies at once. Okay. Ready to do some logarithmic ones? Yeah, thank you for your enthusiasm. You didn't get this answer? Did you put parentheses in your denominator?
No. Oh.
All right, two more examples. Okay, we have a logarithmic equation. My first question to you, is our logarithm by itself? Is the logarithm isolated?
Yeah.
Yes, which means we can rewrite it. You cannot rewrite this into exponential form until the logarithm is by itself. Kind of like yesterday when you were doing your quiz, you had to subtract that 4 over before you could rewrite it as 3 to the negative 4 equals x minus 2. Okay, so how can we rewrite this problem? A raised to the power of 5. There you go. Equals. Excellent. Now, how are we going to get x by itself? Okay, we have a square root over here, right? How do we get rid of this square root? We can square both sides, can't we? If we square both sides, what do we have over here? E to the, thank you, equals. All right. Using your calculator, please find the x. What are you going to type in? What are you going to type in? E to the 10th plus 8. It's going to be a very large number. You're taking e to the 10th power. Who has something for me? John?
2972.958.
Like that? Okay, yes. That is what we should get.
Yes.
John, did you forget to close your parentheses again?
I'll figure it
Get it? Here's our next one. Look at it. Oh, Courtney, what did you say? They have the same base, and we're doing what with them? Oh, what can we do with that? We could condense these, right? We could condense these to log base 2 of excellent. Okay? Now I have a logarithm that equals a value. What can we do? Rewrite it to what?
Oh, 2 squared equals
Great. So we have 4 equals x over x plus 1. Okay? Now we can do some algebra 1 techniques. How do we solve for x? What can we do here? Did you say divide? Yes. Let's multiply that x plus 1 over. So we get 4x plus 4 equals x. So 3x is negative 4. Is that what you mean? So x is negative 4/3. Now remember, when we solve these equations, sometimes things work out algebraically, but they don't make sense in our problem. You need to always check to see if your answer makes sense. This is x equals negative 4/3. Let's look at our original problem. If I plug in negative 4/3, is that okay? Can I have log base 2 of negative 4/3? No. So while we found this solution, it doesn't work, which means this problem has no solution. Okay. Always check to make sure that your solutions make sense back into your original problem. Where you're going to have the biggest issue is when we have numbers inside of a logarithm, because those are restricted. Okay. All right. So what I'll have you do, go ahead and write down your homework, but we're going to do an activity in class. Okay. So write down your homework, and then we're going to work in partners. So that's going to work great because we have an even number now.